Hello guys, welcome. So in this playlist we will be solving previous year questions of communication systems which appeared in GATE, and today we have a question from GATE EC 2024. So this is a question about amplitude modulation. An amplitude modulator has output in volts S of t given by A cos 400 pi t plus B cos 360 pi t plus B cos 440 pi t. So if you see, the three frequencies are 400 pi, 360 pi and 440 pi. So if you were to plot your frequency response, right? So we have one at 400 pi and two sidebands at 360 pi and 440 pi. So this is your carrier and these are your sidebands. Okay, the carrier power normalized to 1 ohm resistance is 50 watts. So in communication systems, we actually also saw in signals and systems that power we always normalize to 1 ohm. So if for A cos 400 pi t, this is in volts, right? So we'll always normalize it as some volt square per ohm, 1 ohm. So we'll write the power just by integrating your V square of t with dt. Ideally the power should be V square by R, right? So R we are normalizing to 1. So it is just V square into dt integral. Okay. And the ratio of total sideband power to the total power is 1 by 9. So total sideband power is power of this plus this. And what is the total power? Total power is this plus this plus this. So this ratio they have given us 1 by 9. And they're asking the value of B. So we need to find the value of B. B is nothing but the sideband amplitude. So before going into the solution, let us see a short review of amplitude modulation. So let's say I have my message signal m of t given by am cos omega m into t. So when we want to transmit it over a long distance, we want an antenna, and for the antenna to radiate properly, its height should be somewhat close to the wavelength of the signal we are supposed to transmit. So usually this omega m is going to be very small. Let's say for the case of your speech signal, this is going to be some 20 to 20 kilohertz, and usable range is approximately like up to 6 kilohertz only. And if you see the wavelength of this, it is approximately around 50 kilometer. So you cannot have such big antenna. So then what we do is we take this message signal and we let it ride on a carrier signal. So we call it C of t, and let me call this as AC cos omega ct. So this omega c, we can usually keep it higher depending on our wavelength constraints. And I can modulate either the carrier's amplitude, frequency, or also the phase by our message signal. So that is where we get our amplitude modulation, frequency modulation and phase modulation. So now coming to amplitude modulation, we said we'll modulate our amplitude. So our signal S of t is given by am cos omega mt into cos of omega ct. So we have modulated our amplitude. So this, if you use your cos A cos B formula, this will be am by 2 into cos of A plus B plus cos of A minus B. So cos of omega c plus omega m into t plus cos of omega c minus omega m into t. So these are nothing but like your sidebands. So from omega c, you have omega c minus omega m and omega c plus omega m. So these are sidebands. And if you always see the power, if you take the power of any cos alpha t, cos square alpha t, the average of this over dt is always half. So the power of this is nothing but am square by 4 integral of cos square omega c plus omega m into t over dt over one time period plus integral of cos square omega c minus omega m into t into dt. So each of these is going to contribute half and half here. So if this was actually b, then this would have been b square. So this will contribute b square by 2 to the power, and this is contributing b square by 2. So this is your amplitude modulation. And in conventional amplitude modulation, what they do is, since the receiver should know what is your carrier frequency, along with this signal, we also send the carrier signal itself. Okay, plus your whatever this signal is. So let me say it is am only in this case, cos omega mt cos omega ct, and this will usually have a higher power than the sidebands, so that the receiver can recover only this thing and use this as your input frequency to get back your message signal. So that will come in demodulation. So I'm not going into that right now. But if you see, this is your equation for your conventional AM. In the case where this carrier is not there, it is called as amplitude modulation with suppressed carrier. Okay. So now if you see the question, this is same as your conventional AM. And now we have understood how AM actually works. So now let us copy this question and go through each line and arrive at the answer. Okay. Okay. So we have our S of t this. So if we draw it in the frequency domain, what will be the power numbers at omega c? Omega c here is 400 pi. And what is your omega m? It is plus minus 40, right? So your omega m is 40 pi. So at omega c, what is your power? Here it is A and it is cos 400 pi t. I have already said if there is a cos term, your power will be A square by 2, right? Similarly for 360 pi and 440 pi also, it is a single cos term. So at omega c plus omega m and omega c minus omega m, here the amplitude is B. So it is B square by 2 and B square by 2 each. And then what they have given, the carrier power normalized to 1 ohm resistance is 50 watts. So what is the carrier here? This is the carrier. What is the carrier power? A square by 2. So A square by 2 is equal to 50 watt. So A square is equal to 100. So what is A here? A is equal to 10 volt, right? So then what they have given, the ratio of total sideband power to the total power. So what is the total sideband power here? It is B square by 2 plus B square by 2. So it is B square. And what is the total power? P total is B square plus your carrier, A square by 2. So this ratio is given as 1 by 9. So B square divided by B square plus A square by 2 is equal to 1 by 9. So now from this we can get the ratio of B and A. So B square into 9 is equal to B square plus A square by 2. 8B square is equal to A square by 2. So A square is equal to 16B square. So A and B are positive. So A is equal to 4B. And what we need to find? We need to find B. So A is 10 volt. B is nothing but it's A by 4. So your B is equal to 10 by 4. Your B is 2.5 volt. So this is your answer. So this is very straightforward, and if you're just confident with your signals and systems basics, communication system is very straightforward to solve. So many textbooks, they'll confuse you with something called as your modulation index mu. So this is nothing but your ratio of your amplitude of your message signal to amplitude of your carrier in this equation. So this we can also rewrite it as AC cos omega ct plus mu AC cos omega mt cos omega ct. But in this question, they have actually separated that this cos omega m omega c into cos omega c plus omega m and cos omega c minus omega m. So if you try to go back to this and then try to find your mu and then you have to memorize your formula of your sideband to your total power in terms of mu, right? And then you have to substitute it. So these are all not required. Just plain basics. You read the question, interpret what is given, you try to map it to what you already know and try to get the answer. As simple as that.